Today's products are built on iteration, version after version, creating the illusion of progress. It's time to stop thinking about the future and start thinking from the future. Not only create the product itself, but also reinvent the process that makes it. 100 years ago, the assembly line revolutionized transportation. But the same approach is still in place today, only more complicated and much longer. A process that limits innovation and requires enormous investment. So we started again with a single smart production cell, designing for total robotic assembly. Each cell capable of building any of our vehicles, modular and scalable. We've named it the MicroFactory. Installed in existing warehouses, they start production quickly at a fraction of the cost, making vehicles locally to be used locally, empowering the communities they serve. These microfactories can be deployed all over the globe, making electric vehicles better and affordable to all. This is the next transport revolution.
Any conventional factory is still based on the model of the conveyor belt from the 1950s or Henry IV. The product goes through all the stations in a serial way. If you want to produce multiple products in the same place, in a serial system you cannot do that because the full system is specifically designed to produce one product, one vehicle. We are revolutionizing all of this. The MicroFactory fixes all these problems.
I'm Mike. I lead Arrival Automotive. A typical automotive assembly plant will cover millions of square feet. Because you have to invest so much money to set up the factory, you then have to produce hundreds of thousands of vehicles. You're way overproducing for that local region. Our microfactories cover a couple of 100,000 square feet. Our van microfactory, for instance, is sized to build 10,000 vans a year when we're operating on 2 shifts. And at that size, we believe a metro area can support almost all of that demand. We're doing things nobody else has done before, and it takes a very unique mix of talents that bring that to life.
Hi, this is Napo. I'm the Chief of Mobile Robotics here at Arrival. The MicroFactory is basically built around 2 main components. The robotic cell, which is the factory inside the factory. Think about it as a cluster of robotic arms. It's completely driven by computer vision and several forms of AI-based control. And then you have the glue connecting all the elements inside the factory, all the cells. This technology is mobile robotics. So robots that move in the environment autonomously, robots that interact with the cells and with any other robotic factory. We are reactive, we are adaptable, we are reconfigurable. This is the DNA of the MicroFactory.
The cell architecture is really exciting and it's really unique. My name is Raj Vyas. My role is to develop the assembly processes which allow us to build these microfactories. We're developing these microfactory cells, on average 20 meters by 20 meters, and those cells allow us to build a huge number of different products. That gives us scalability, modularity, and automation.
We aren't really a vehicle manufacturing company, and I say that because if you look at the people in the company, half of them are software engineers. So We are, at our heart, a tech company. So I can tell you that's dramatically different than a traditional vehicle manufacturer. One of the great enablers of the microfactory approach is keeping the capital, the investment in the microfactory relatively low, because that's what allows us to build many of them. And so in the case of robots, we are buying very standard robots that several different companies produce. What we're developing inside the company is very sophisticated software.
In robotics, semantics is the study of understanding. How does the robot calculate its location in the space inside the microfactory? By developing AI tools to calculate all these features of semantics, we build systems that are capable of interacting. This is extremely powerful because we are basically moving from what I would call the glorified automation to advanced robotics on the shop floor. It's a key feature of the microfactory.
Our software team, they're developing advanced vision systems. Our goal is to put those vision systems on these robots. So the robot will go into a particular location, pick up certain parts, and identify where those parts are using advanced sensors. Once they've identified those parts, pick those parts up and locate them into position.
We're supporting this idea of local manufacturing, and we're part of a community. We're not only creating jobs, we're paying taxes. We really see this idea of distributed manufacturing as a much more beneficial model to the communities where we're located than the more traditional approach.
The microfactory concept is phenomenal. The product is made here, it stays locally, and it's electric. That helps our air quality and it helps our citizens. My name is David Swenson. I'm the Director for Economic Development in York County, South Carolina. The economic impact, can't say enough about the investment that's being made, the fiscal impact that has in our community, the social impact of what it will do to bring jobs, and the interaction our community will have with a cutting-edge technology company making electric vehicles is exciting.
Our vision is, over time, hundreds of microfactories scattered all over the world. It's not a question about are there even more opportunities, it's which opportunities do we want to explore first. We're using microfactories and the microfactory approach to produce vehicles, but I don't see any reason why this same idea can't be applied to other manufactured goods. The most profound technologies are the ones that become interwoven into the way that you live your life and the way that the society operates. And eventually they become such an integral part of the way things are done that you forget they're there. They just become the way that things are done. And I think what Arrival is developing could well be technologies along those lines.
I'm getting this question like why Arrival is different many times, and I would say that actually everything is different. People, culture, technologies we are using, materials, components, method of manufacturing. The only thing which probably similar to other companies is that our products called van and bus, but everything else is different. Automotive industry, in the way how it is now, was developing for more than 100 years, and it was a lot of innovations and a lot of optimization with the process. And today we believe that industry is on the maximum level of efficiency. What we understood today that it's not enough, because we still get vehicles which are expensive and that are not sustainable. And that's why we started Arrival in January 2015 with the idea to reinvent the way vehicles are made.
One of the things that makes our approach different is our microfactory approach to assembling and manufacturing vehicles. A microfactory is a much, much simpler process as compared to a legacy automotive manufacturing plant. A typical automotive assembly plant takes literally years to construct. We can do that whole thing in 6 months or less. So it's maybe 1/6 the amount of time and maybe 1/10 of the capex, if that.
The vehicle, the way how they designed today, cannot be assembled by microfactories. The vehicle must be designed to be assembled by microfactories. If you take a normal car today, only to make the body system, you need to have at least 1,000 robots. In our case, all assembly process is less than 70 robots.
The brief was really clear from the start. How do we build vehicles at price parity with a conventional diesel vehicle? Now, what that means when you're putting a large, expensive, heavy battery into a vehicle is that you need to make the body system lighter and lower cost. If you were to take a conventional steel panel and compare it to ours, then we're less than half the weight. The materials that we're developing are thermoplastic-based composites, and we can recycle those an infinite number of times. We have far higher ductility, and what that means is the panel rebounds from impact. So rather than having to repair or replace, our panels actually survive much longer out in the field, massively reducing the potential repair bills for our customers.
When you look at our elements components, they're modular. They're based on a 10 by 10 grid. They're stackable. They're plug and play. It's amazing. Designing our products ourselves, owning the IP, giving us the ability to upgrade that, prioritize the products that we need. It's easy installation, easy replacement, agility for the future.
We invented grid-based components, new material technologies to do the body systems, and a new software to manage our factories, and also in-vehicle software. So if you combine all those things together, microfactories, components, materials, and the software, those are enabling technologies which makes it possible to make best-in-class vehicles.
We always get the question, why commercial vehicles first? And it's actually because it's an underserved market. So right now you have very few vehicles that you can go and get, and you're not able to do anything bespoke or custom with those vehicles. You get what you get. It's a market that cares about the total cost of operating, which electric vehicles enable, and Arrival further enhances that. And then it's a growing market. It's a large segment. There's 2 million vans by 2025, a total addressable market of over 280 billion. And Arrival has the best-in-class product. We're able to scale rapidly. We're able to really use the technologies to enable these customers to improve their operations. We can work with cities and customers, and we can create those at any volume, again, using the same microfactory. So it's a win-win on both sides.
It's a perfect time for companies like us to step into this industry and actually change it. We found a way how to break the rule of economy of scale. We have much better product, green product, but it also has better pricing as well. And this perfect combination where you don't need to have a compromise between being green or being efficient. So with our products, it comes together.
I'm Rob Thompson, Chief of Materials at Arrival. The way it began was, Dennis was really clear at the start. He was like, with everything that you know, how would you build a vehicle now? What's really exciting in the world of materials? And so that's where we started from. We just dug into where all the development was, where robotics was going, where polymer chemistry was being developed, where recycling was strongest. We looked at all the key players and all of the opportunities that presented themselves. The brief was really clear from the start. How do we build vehicles at price parity with a conventional diesel vehicle? Now, what that means when you're putting a large, expensive, heavy battery into a vehicle is that you need to make the body system lighter and lower cost. We rethought the vehicle architecture and rethought the materials to create something genuinely new. We've taken a completely different approach, a radical approach to how we make our vehicles. So we're using distributed microfactories, and that means that we needed to develop materials and processes that could fit that model. So we needed to do away with the big, heavy, expensive steel stamping tools, paint lines, welding lines, these things that cost billions to set up and are with a company for years, decades even. We wanted to establish a very nimble and agile approach to manufacturing. You have to develop the material and the process together to achieve the microfactory model. If you were setting up a production line for a conventional metal stamped car, then you're looking at something like €1 million a square metre for the tooling and a 12-month lead time. Now with our process, we've got that lead time down to just a few weeks, and our tooling investment is tens of thousands instead of millions. So we can turn around products very quickly, we can go from prototype to production very quickly, and it really supports this microfactory model. So everything starts from a fabric. All that we're doing is fabric based. And like that in itself is fundamentally new. We're trying to build all of the performance that we want in the finished material into fabrics. And so what we're doing is we're mixing the garment industry, conventional textile industry, automation, and we're bringing those things together. And so we're finding this, really nice serendipity in some places that we just wouldn't have discovered if we weren't mixing these different industries together. And it's got us to the stage where we bring rolls of fabric into the factory and we deliver finished panels to the vehicles at the other end of the factory.
My name is John Steele and I'm the Head of Sustainability at Arrival. Our composite materials are fully recyclable, so any waste that's generated during the process can be reused and recycled into new products. We're doing this from the two kind of sources of waste. There's materials that come from offcuts from the ply cutter, and there's materials that come from the trimming process once the material's been moulded. Both of these materials have the potential to produce new components for vehicles, or they could be reused in other applications.
If you were to take a conventional steel panel and compare it to ours, then we're less than half the weight. If we take 125 kilos out of a conventional body system, then that equals something like 10 kilometres range per charge, or about 800 kilos of CO2 in the lifetime of a vehicle. So through this material development, we're making a significant impact on the sustainability of the vehicle too. Now what we can do with a composite material that you can't do with monolithics like metals is that we can build in additional strength where we need it. We have far higher ductility. So in a low-speed impact where you'd expect to have to replace the metallic body system, our panels actually bounce back from that and don't require replacement. So rather than having to repair or replace, our panels actually survive much longer out in the field. So massively reducing the potential repair bills for our customers. I've worked on material development for a long time, and you have to have a lot of faith in the opportunities that materials present, and it takes a certain type of culture to understand the opportunities of that. There's very few places in the world where you could do the sort of work that we're doing. And at Arrival, the collaboration between the teams, the trust between the teams, it's unlike anywhere else that I've been, and it means that innovations like this they can really thrive, and the whole organisation gets behind an opportunity, whether it be an engineering opportunity or a material development or a robotic solution, and they help bring that to life. Hi, I'm Rob and I lead the materials division at Arrival. We're here in our first microfactory in Bicester, where we are building cells to manufacture the composite panels for the assembly line. As you can see behind me, those cells are taking shape. So we've moved into a conventional warehouse. We haven't made any significant changes to the structure. Power drops came in 6 weeks ago and the cells are operational, so we can move at incredible speed. So if we go around and into the cell, I can show you a little bit about how it works. So the raw material comes in off a roll. As that material comes through, The software, the factory software, is indicating to the machine just in time exactly what we want made out of that piece of fabric. So actually the machines are incredibly responsive because they're being driven by our software. So we can make different components almost instantaneously, and the factory reconfigures according to need. The fabric comes through, it's cut to shape. The end effector here collects the pieces of material, and then it deposits those in a stack as what we call a kit. And that kit forms the foundation of the moulding process. Everything that runs through this production line has to be utilised. All of the waste material that comes off here is collected and is reprocessed back into a material that we can use in our body panels. We've gone from a kitting step to a moulding step. Now, we have developed solutions for the materials, the moulding process and the mechanisms of moulding to achieve a low capex, light footprint manufacturing concept in a warehouse. It's a really fundamental part of the process, how these steps come together without having to invest in heavy presses, heavy machinery, and all of the capex implications and complications that come with doing that. So the factory is very versatile, and as you can see, the moulds are on static tables, but it's only a matter of time before they're replaced with AMRs. And in fact, AMRs are fundamental to the MicroFactory story because it allows us to configure cells however we see fit, and the AMRs provide that linkage. So the AMR will bring the kit from the kitting cell into the moulding cell. The moulding cell will carry out the consolidation cycle, and from here we'll take the moulded part into the trimming step. So with everything we're doing, the goal is to try and keep the tooling costs as low as possible and the process is as dynamic as possible. As parts are coming through, we're learning how those parts need to adapt and evolve to improve, say, fit and finish on the vehicle or ergonomics, gaps and tolerances, stuff like that. Now, the way we're approaching all of our tooling, jigs, fixtures, processes, it allows us to make changes very fast and without significant cost. Now, the technology cells, the factory itself, it has to keep up with that process. It has to be able to adapt and change. That's where the AMRs come in, but also how the footprint of these cells come in. So building everything on grid-based architecture, and also understanding how the cells can adapt and change using common robotics, for example, common systems of interaction in our robotics, common software platform. All of these things help to drive an extremely agile approach. So you can see with this cell, what we've tried to do is get as much utilisation out of the footprint of the cell as possible and avoid tool changeovers. It's a big challenge for manufacturing. Jigs and fixtures are mounted on A-frames which are rotating, so the robot is in full utilisation, jigs and fixtures are in full utilisation, and we get maximum throughput with the minimum footprint possible. So if we go in, you can see this kind of scale of this cell and the scale of the robot. A lot of what we're doing is to try and standardise these robots and the processes that we use, and the interactions between the robotic elements and the software within the cell. So all of this is modular. The parts and the robots and the process, they work together in harmony. It's not like a conventional production line where each robot carries out a part of the sequence of events. Actually here, with a tool changer, one robot can carry out many functions. If I walk around here, I can show you an example of a part that's just been trimmed. Now, typically, this is where a part is finished. The trimming process is the last step in the sequence of events. But in some cases, actually, the part requires assembly, either to another composite panel or to a metallic or other structure. And that's where we go onto the next cell to see the assembly process. So this is the last cell, the last stage in the composite part production. The robots behind working with tool changers allow us to go from single panels to complex multi-part assemblies that are ready for assembly onto the vehicle. So the composite parts, they come off the production finished. It's a really important part, this, because it's about how we are able to distribute manufacturing. We don't have to install the big baths that you would expect with paint lines, with conventional metal stamp body systems. We can move into a warehouse and have a factory up and running in a matter of months or even weeks, and it gives us that agility that's so important to our engineering and design approach.
The arrival trunk is really interesting because it crosses over between asking quite functional questions and turning those functional questions into almost an art-based execution.
The circularity dimension of the project is super exciting. We start with a fiber, we weave it, we press it, or we make something, and then we return it back to that powder. The ability for Arrival to take its manufacturing process, which is built on that idea, and create this coveted heirloom item is really interesting.
The microfactory has become an incredibly versatile playground for building different types of product from the same material building blocks. We're using the same materials to make the trunk as we do for our vehicles.
I'm Ansel, I'm the design director at the visual image studio at Louis Vuitton. We design all of the windows worldwide. The windows are quite an interesting space because they're very democratic, really, almost like street theatre. They're there for everybody to see. Louis 200 is the celebration of Monsieur Louis Vuitton's 200th birthday. We've approached approximately 200 visionaries or people doing really interesting things now as a way of sharing ideas and creativity within the window space. It was a celebration of creativity and innovation, and also how that relates to our current climate and ecology. We're bringing that discussion to the street, to the public, to culture as part of culture.
My name's Adrian Nyman, and I'm the SVP of Brand and Marketing for Arrival. When we think about the mission that we're on as a company to really modernize not just electric vehicles, but the way they're made with circularity from day one.
Our aim was really to look forwards and look at how people are innovating now. There are similarities between what Louis was doing at that time and what Arrival are doing now.
My name's Rob, and I'm SVP of Materials at Arrival. The brief was to take the original trunk by Louis Vuitton and rebuild and redesign it in our materials. And so we took the key characteristics of the trunk and transferred them to a design that was suitable for production in our microfactory. A lot of the tools that we've been developing along this journey have enabled us to be able to turn product around very fast. You know, the Louis Vuitton trunk project came in, we were able to go from CAD to finished part in a matter of weeks. That's very unlike a conventional automotive factory. What's incredible about the trunk is it's a zero-waste product from the start. In the microfactory, everything that goes in should go out as a final product, and every final product should be 100% recyclable. So we can recycle the entire trunk at the end of its useful life.
The Louis Vuitton trunk is an iconic object. It's like a vessel for different ideas to combine new thinking and innovation and these technological ideas of the future and dealing with the challenges now.
There's this really beautiful synergy between what we are doing and what Louis Vuitton is famous for in his innovation.
The production method that Arrival's pioneering is incredibly agile, it's zero waste, it's local, it's traceable, and it doesn't require us to overproduce to make it profitable. It's going to have real impact, not just the way EVs are made, but how everything's made. This collaboration demonstrates that beautifully, and it allows people to engage with these powerful new ideas.